Hello, my name is Sven Geissen. I'm professor at the Technical University of Berlin, and I'm chairing the breakout session Industrial Use Concepts. And I'm very proud to introduce to you two of my colleagues. The first one who will start is Tibor Kretschmann from Envirochemie, and he studied process engineering before he went into industry, worked for a company before he joined Envirochemie 5 years ago, and is responsible for process engineering of water recycling and membrane technology in process water treatment applications. So, Tibor, the floor is yours.
Yeah, thank you, Mr. Geissen. I will share my presentation. To give you all a short introduction of my company. Okay, please as well a short feedback if presentation can be seen.
Yeah, but not in the presentation mode until now.
Yeah.
Yes, now.
Now it's working. Okay. Thank you. I just have to get away the image here. Yes. Okay, yeah, so welcome to short company presentation for Envirochemie. Plants and services for industrial water and wastewater treatment with the objective to preserving energy and resources. What we do is industry, water treatment, wastewater treatment, water recycling. For industry clients, we do not work for municipal clients. And within the industry, we really handle every part where water plays a role, from water purification at the intake side to wastewater pre-treatment, water recycling, internal partial flow treatment, cooling towers as well. All imaginable within contact in water in the industry. Our services, we start with consulting, do the planning for our clients, design and installation. We do as well the plant operation and maintenance. We produce our own water chemicals. We have the full range of services required to operate the plants. We have now as well digital services for plant automation, plant control, industry 4.0, let's say. And we do a lot of plant optimization in ongoing process. The company has now more than 45 years of experience in the market. We now have a turnover of more than 200 million euros a year, 900 engineers in our company, more than 30,000 active service customers, and a localized structure close to our customers. This is where we are mainly active, Europe and Russia. We have as well some presentations in other parts of the world, but our main area is Europe and close areas to Europe, let's say Morocco, for example, or Russia. These are our locations within Germany. Our main places in Rostock, near Frankfurt Airport here, and near the city of Darmstadt. But we have a lot of subsidiaries here in Germany to do mainly services all over the country. Our industry experts examine process in a holistic way. So we do a lot of different projects. We have a lot of knowledge in different industries. The ones shown here are not. We are not limited to these industries, but let's say these are the main industries for us. What is food and beverage? The chemical industry, steel, metal, surface technologies, life science, pharmaceutical. Mining is very strong, for example, in Russia. And others. The Enviro Water Group is getting bigger, it's growing, let's say, where the envirochemie, is the head of the organization, let's say, and mainly focused on industrial wastewater treatment and water recycling. We do everything that is individual plants and individual processes. And our subsidiaries and daughter companies are then more specialized. For example, the EnviroFalk company, which is specialized in more standardized plants in ultra pure water, for example, and water for pharmaceutical industry. Innovac, for example, is a company specialized in water chemistry, especially for cooling water systems. And Up2E is a company specialized in advanced oxidation processes for special applications, so really highly polluted wastewaters to purify. As already told you, we do the consulting and planning. This is where we most likely start with. The individual problem from the client, we do then the consulting. We help him with lab and pilot test if it's necessary. If there has to be developed something new, we do start with lab and pilot tests, and we do studies and concepts. And then later on the planning and approval for planning. We do construct the plants our own. We have a production area of more than 50,000 square meters only in Rostov. We do as well electrical engineering, automation, and everything is executed by specialized staff. Some words to the different technologies, just examples, but the membrane processes, they're called in our house, we call them the EnvoPur processes, which is obviously microfiltration, ultrafiltration, nano and filtration and reverse osmosis. And the biological and wastewater treatment, for example, aerobic and anaerobic treatments we do have there. All the different types of technologies you might already know. Membrane bioreactors, nitrification, denitrification, anaerobic activated sludge processes, and so on. We have the physicochemical processes as well, the very classical precipitation, flocculation, sedimentation, neutralization, filtration, of course, ion exchange, and advanced oxidation processes. And we're very specialized as well in the dissolved air flotation systems, which are called FLOMAR. Important for us is our pre-assembled processes. We do not pre-assemble all the equipment we supply, but for example, here again on this picture, you can see one of our biggest pre-assembled plants. This is was a pre-assembled modular system with mainly flotation process and precipitation flocculation for a mining client in Russia. And we pre-assemble the modules in Germany within our plant, and then bring the parts to the client, do the final assembly, which is really just putting together the Lego parts, let's say, the Lego bricks, and then directly can start to operate the plants. We have as well not only big projects, big plants for high volumes to treat. We have as well very compact small plants for applications with lower volumes to treat. This is where we originally came from 45 years ago, but still very important in the market, and there is still a lot of applications for small amount of wastewater to treat. It's not, you can see here physicochemical processes, flotation processes, batch processes, but we're not limited to them. But this is main part, let's say, of the compact plants. we developed specialty wastewater treatment and water treatment products, chemical products for our clients' applications. Yeah, this is very important. Yeah, because it's always a part in water treatment that plays an important role, and we have a lot of knowledge, and our own production side, our own laboratory, where we develop really for the individual task the perfect chemical, let's say. Yeah, our customer service, a key for us to help the client always, to be with him, not only planning and not only doing the planning and installation for the plant. We can help for the whole life cycle of the client's plants to keep operating the plant always. We're as well, we are doing more and more operation and contracting for our clients. That means that from just helping them with operation, we do until the investment for the client. So some clients are very interested to just pay, let's say, the treated cubic meters. And that's what we do. We install the whole plant, we do the investment, and we operate and give the whole service to the client. Just receives the task, which just receives the wastewater, and then do everything. Digital water management, getting more and more important as well. And I'm not going too deep into detail. I mean, most of you maybe can imagine what it is. You can connect from everywhere you are directly to your plant. You can see all the values. You can see all the curves. You can really be connected always to your treatment system, and be up to date and can operate from where you want to. Therefore, you have a very good process control always. Research and development is very important for us as well. We are there involved with different partners and different kind of research and development projects. Social commitment as well is important for us. We have there always some ongoing projects we support. And that's all for now with a very brief, short presentation. Thank you for your attention.
Thank you very much, Tibor. However, it was more or less a presentation of your company's activities, but what we are looking for is solutions. Can you please give us some examples about solutions which you have installed for industrial water reuse? And maybe some examples of, let's say, established technologies and emerging technologies in the field of industrial water reuse.
So just give me a moment to come back into the window to share. I think I still am sharing my. Sorry for that. Okay.
Nevertheless, you can.
I'm still sharing I think I'm not sharing anymore my screen. Is this correct? I'm not sure if I'm still sharing my screen or not.
Mr. Meyer, you can answer this question. I'm not able to do so.
Yeah, you're still sharing your presentation.
Okay.
So maybe you have to close that presentation and then open the other one.
However, meanwhile, to the audience, if you have any questions to Mr. Kretschmann, please type your questions into the chat. And as we are a small group, you are also allowed to switch on your microphone and ask questions directly. Meanwhile, Mr. Kretschmann will give us, will prepare some presentation about solutions. For me, it would be also interesting to note what would be the percentage of projects realized in the last years in the industrial water context. which are addressing water reuse in contrast to wastewater treatment, let's say. But Mr. Kretschmann is now into this presentation.
It's working.
Yeah.
So I think we don't have to lose time.
So please go on. I'm just looking for the correct thing to press in. I will be there within a minute, but yes, I have to look. I'm a bit off grid now and not so connected to the server. So yeah, just a moment. Sorry for that. But I have something in mind. Then yeah, please.
Maybe Mr. Kretschmann, we postpone it. We postpone it after the presentation of Niels Groth. And meanwhile, there is one question from Nina Streckwall.
Yes, thank you. I have a question concerning the operation of the plants that you showed us, because you said next to consulting, you also do operation of the plants. But once you hand over the operation to the industry, do you see risks in the operation then? Because especially in the international scale, sometimes knowledge is lost in that step. How do you see that?
Yeah, I mean that's right, and that's why we offering it to be there with an operation. Obviously, it's the best when our experts are there, and it's with the online support, which is getting more and more normal, let's say, for the clients as well. It's easier to help them as well with all the operation from far away. If you're not there directly with your own personnel, but water treatment has still a need of some experienced personnel doing work there. Therefore, some clients already take the decisions to do not anything their own. But give it totally in our hands. And it's different. It's different from country to country. It's different from client to client, from industry to industry. For example, in the food industry, in the milk industry, for example, we see that the clients are very connected to all the issues regarding water, and they do know very they are very good in what they do, and there's no problem for them to operate a process from us, so we can give it to them very, very quickly, and then it's working. But there are other different industries. Yes.
Okay, Tibor, thank you very much. Last question from my side, talking briefly about the costs per cubic meter. So finally, very simplified. I know that it's case dependent for sure, but for us estimate, I think all of us are very interested in getting some information about that. We have learned, and everyone knows, production without water is not possible. Therefore, it's an essential must. But however, we know that we have also the MBA and the controller people amongst us in the industry who are looking carefully for the numbers.
There has to be a payback always, of course. Greenwashing is a bad word, but it's not sufficient to just do it for image questions. It's really necessary to have a return of invest, and then it depends really on what you pay for fresh water, and we then do the concept, and then we can exactly calculate if there will be a payback or not, and that's normally the way it goes. If there's a payback, we go deeper in, and normally then it's realized. And from the technical point of view, a lot of stuff is possible, but has to be a payback. If not, there's no project.
Okay.
Up to now.
So I've learned. The overall sustainability plays more and more role, in particular in large companies. And now I'm turning to Niels Groth. I'm very proud to introduce him, and it might be different at Dow Chemicals that you are looking not only on the cost, but more on the long-term perspective. First of all, with respect to sustainability and water supply. However, short introduction to Niels. He studied chemical technology at Eindhoven University, made a PhD. So Dr. Niels Groth, excuse me. And he made his PhD in catalysis and started his career at Dow in the research and development department. It's usual for large companies. And currently he is within the Environmental Technology Center as a specialist on water and wastewater system, supporting plants globally. And over the past decades, he leading different teams to develop and implement a regional water management strategy for the Dow Terneuzen site. By the way, not forget to mention, he was also professor from 2011 to 2021. Oh, it's right, at the University of Applied Science in Wissening, the Netherlands. So Niels, the floor is yours.
Thanks a lot, Sven. Very glad to have the opportunity here to present some stuff about Dow. And I'll start sharing my screen. Should come in presentation mode soon, I hope.
Yes, but
should be there.
Yes.
Okay. Yeah. So I'll talk about our. Sorry.
No, it's okay. It's okay. Perfect. Yeah. Thank you.
Okay. There we go. So I'll talk about our water reuse concepts in the light of the global challenges we are facing today in society and the chemical industry. Show you how we make that transparent by dividing it in actually 3 pillars of water circularity, and by that is creating a kind of next level of sustainable water use. Yeah, Dow, as a very quick introduction, we are a global company, chemical companies, about 37,000 employees across the globe, headquarters in the US, but present in all the continents, as you can see, producing chemicals for different sectors. And yeah, talking about water, beyond the global challenges of more food, more energy, more water, we are also facing, say, a transition in raw material and energy in the next decades, as we all know, and that's putting even more stress on water provision to the industry. Not only these, but also climate change, of course, is a major factor which will increase freshwater stress in several areas, especially in coastal regions, where we are facing say salinization and then from time to time also droughts. Most of our facilities operate in a watershed where water in fact is yeah, it's local, but it's also finite and it's shared with others. So you have to deal with other partners across the fence, not just industry, but also public parties and others to distribute water at each convenience. And it's our philosophy that most industries, and especially chemical industry, actually they can source and upgrade what we call secondhand water, and not rely on any source of potable water which is precious and determined for human consumption and food. So that's more or less our philosophy, and that's driving our approach globally. Within Dow, we have defined our what we call priority water stress sites, the major locations across the globe where we are really feeling a severe water stress, and that may be at the gate, say water availability, water quality, but it may also be at the back end where we have issues for discharging effluents. And for these sites, we have defined our objective to reduce our water intensity by 20% before 2025. And each of these plants, and you see a couple of these are located in Europe. Berlin, for example, is in Germany, near Leipzig, Terneuzen in the Netherlands, and Tarragona in Spain. And each of these plants have to come up with plans to mitigate their water footprint, achieving that goal of 20% reduction. And each of these plans, of course, will be very different because all the circumstances are very different. Nevertheless, we try to make our approach as transparent as possible by using metrics for different areas in our water use. And that also helps us to set the right targets. So we distinguish actually between freshwater source circularity. So within the watershed, what kind of alternatives are there for, say, non-virgin water, so the so-called second-hand water. And then, well, within the processes, how can we optimize our processes, reducing our intrinsic water footprint? Can we develop processes which demand less water for heating and cooling? That's especially important in the next decades, where we go through that energy and raw material transition, where we have to adapt our processes significantly. So that's a real opportunity to address the water paragraph as well, and reduce the demand for water. So on top of that, internal recycles and reuse where we can. And then finally, the discharge circularity. As we improve water quality, it also becomes easier to start reusing effluents. And that's also what we have been showing in the past decade already. If we go to an example for Dow in Terneuzen, where I've been working for the past 3 decades. We are a major site here with about 3,000 employees, requiring more than 20 million cubes of fresh water annually in a region which has a total demand maybe of 30 million. So we are a major player there, and that makes us also responsible. The whole area has abundant brackish water, but so to say, very limited amounts of fresh water. There's just a very minor amount, and we are more or less relying on, say, more creative solutions on top of a connection to the Biesbos area, which is in the middle of the country. You can see that somewhere there. And try to make my pointer here, but it's not. That's not really working. In the middle of the country, there's the source of fresh water, supplying the whole region of potable water. That's a source which is predominantly meant for potable water production for the whole southwest of the Netherlands, and we do want to get away from that source ultimately to be sure that we are not impacted by competition with potable water. If you look at this pie chart here at the left, over the past 2 decades, we have realized now a situation where we have about 75% of our water supply coming from these what we call second-hand sources. In the middle, you have this little picture here which shows that we are reclaiming a part of our effluent of the wastewater treatment plant at the Terneuzen site. We have segregated our site in 2 parts with saline and fresh wastewater, and the fresh wastewater then is treated and recycled back to a major cooling tower. The second step of reuse we realized by collaborating with the water company Evides and the water board in the region, who are treating the effluent of the city of Terneuzen, and that portion also is being reused at the Dow premises after upgrading by Evides. There's a major portion as well on the top left of the pie chart, which is internal return streams of steam condensates and slightly polluted condensates, which are returning into the demi-water grid. And then on top of that, some surface water coming from the Belgium polders, which is actually agricultural runoff, and instead of being discharged to the sea, we are using that as industry water. So that leaves us with a portion at the bottom of the pie chart, which comes from that Biesbos area, which we want to replace by regional sources in the next coming years. We have a couple of projects in place here, and you can see the circles in the scheme at the right and at the bottom. And the one with the red dot, that's actually how we are going to close that gap of 25% within the next 2 years. So I'll come to that a little bit later. On top of that, we have projects in the upper circle where we are going to reduce our internal water footprint on site, mostly via a European Spire project called Aquaspice. And then in the bottom, we are developing a backup of fresh water by underground so subsurface storage of fresh water together with farmers in that region, where both farmers and the industry can benefit from. Coming back to that red dot, what we are going to do in the next couple of years is to reuse even more of the effluent of our own wastewater treatment plant and of the Terneuzen City wastewater treatment plant. So we are roughly going to double these amounts, and on top of that also start reusing collected rainwater. That in total, that's about 8 million cubes of water, which we will then lead through a constructed wetland and then feed it to a desalination unit to produce high quality water, which can then be reused at Dow. The objective of the constructed wetland, and we did a pilot over the past 2 years, where you can see a snapshot here, is to produce very stable water, which can be fed to a desalination train with membrane systems, which are less vulnerable to fouling by that stabilization up front. And indeed, that's what we saw in these pilots over the past 2 years, that we really achieved a water quality which is very stable and which has very little biofilm formation tendency. So that's a very promising, and the intent is to make an upscaling in the next 2 years to a system, and this is an artistic impression, of course, where we are going to treat about 1,000 cube per hour through wetlands and then through that desalination train, which then should be in operation by 2025. So with that, we will achieve our objective of 100% second-hand water use for our facility in Terneuzen. And if you look at our, say, overall objectives, we are making nice steps into our sustainability journey, because these type of projects can be copied to other industries and sectors in Dow, but also externally maybe. We are really benefiting from over the fence collaboration with other parties, which is also, of course, beneficial by getting subsidies from European and national funds, and we try to make everything as transparent as possible to be sure that we do the right things on the long term. And that's what I'll like to share with you. Thank you. If there are questions, I'll love to answer them.
Yes, thank you very much, Niels, for this very interesting presentation about your strategy with respect to water management. I would call it water management. It's not only water reuse, as you showed, but water management in general, and very strategic with implementation of research projects, but also with a long-term strategy within Dow. So the floor is open for questions. If you have one question, please, you can unmute your phone or your microphone. It's possible, as we are not many people. Let's say we are in total 47 now. That would be okay. Nevertheless, my first question is related to the concentrates. So water reuse generally is, let's say, already solved, I would say. We have a lot of technologies available in order to produce high quality water. Even though post-treatment of permeates from reverse osmosis are applied, where we experience long-term experience in Orange County, for example, etc. But what's about the concentrates, Niels?
Yeah, that's a very good question, of course, and that yeah, each of the locations will have their own solutions there. In the Terneuzen situation, we are pretty lucky being at the shore, so we are close to seawater, which is actually available there to receive these kind of concentrates without any issues. But yeah, in other areas, you need to go to other type of solutions, and that will be in general a more intensive, energy intensive solution. Although there are also possibilities to reuse some of these concentrates. For example, you can start using these for regeneration purposes or flushing, and at least make a second-hand or third-hand use of these streams before you have come to a final conclusion. But somewhere at the end, if you are really stuck with salts, then you have either to concentrate them even further, or even crystallize them if possible, or find other ways like salt products. But the business case is not very good in general.
Yeah, that's right. However, my last question is with respect to the costs. Did you have a lot of discussions internally while promoting this strategy with respect to costs, or did you get support from the board, for example, with respect to being independent? You also addressed the different water users in the region, or generally the households, the agriculture, the environment, for sure.
Yeah, of course, cost is an important factor, but we had the opportunity to combine, say, these kind of opportunities with also internal drivers. It's not just the sustainability journey, but it's also, say, reliability in our processes. For the example I gave you of the project we are currently working on, where we will produce a very high quality water, that will replace a lower quality water, and with that higher quality water, we could convince the receiving facilities that they will be better off. Although they are going to pay more, long term they will benefit, because they will have less water demand, they will have less chemicals, they will have less maintenance and inspections, and they may overcome, say, turnaround periods of 8 to 10 years instead of 4 to 5. And that's a huge cost factor, and by that there's even a positive benefit of the whole project. And that's you need to be kind of creative, of course, to find these kind of combinations, but it's important to have your strategy ready to act if the opportunity is there.
So there is one question in the chat from Harsha Phillips. What would be the decision factors regarding minimum liquid discharge versus zero liquid discharge when considering industrial wastewater use? Can you share examples when to use each of them? So maybe Niels first and then Tibor second.
Yeah, well, I think we would focus on near to zero liquid discharge if possible, because that last piece of going to real zero, that has such an energy burden that it's that the overall benefit may be very doubtful. But it's very much dependent on the local circumstances, what your abilities are to get rid of these concentrates.
And Tibor?
Yeah, what I can say is that we are, we have a lot of discussions, a lot of projects in this area, zero liquid discharge, where we, do the concepts with the clients, and then they soon come to an end, let's say, because then it comes to very high costs for this last bit Niels told us. That's always the problem. And it's a question of time. I mean, a question of energy, of course, but a question of time, and someone might move to another place or gets another solution to bring away the water or something. It's not dischargeable anymore in its place. But from the technological point of view, it's not too difficult, let's say. We can handle this very good, but the energy cost, and mainly for the last step, that's evaporation, crystallization, that's a real problem, a real issue. So we have realized projects, but really not too much. Maybe some 10 to 15 projects, but with smaller footprints as well. Some cubic meters, let's say, of highly polluted wastewater, where there's really a benefit, because the discharge is impossible, and to bring it away under the like highly contaminated, put it somewhere it's not so possible. Then you burn then what's the last bit of dry residue, you can burn it then, so it's okay. yeah, that's
yeah, depending, also depending, as you know, it's depending on the residual organics. You collect in everything with the membranes, by the membranes, so everything which is in the water. So which is swimming, floating, whatever is dissolved in the water. And therefore, it's quite challenging, but it's, as you mentioned, case dependent. However, as soon as we are reaching going over the discharge limit, it becomes complex, no? Then and becomes more costly. That's for sure. Now, the easiest way to discharge and the most efficient way is to discharge. However, if we are coming over this point, it makes sense to increase the concentration more, and then we are moving into minimized liquid discharge. However, you also have to answer the question what to do with the residual liquids at the end of the day. Liquid discharge in Germany is about 300, 400 euros per ton. No? So that's plus transporting, and incineration about 600. So something you have to discuss. You have to discuss with respect to the local conditions, also with respect to money, but also with respect to sustainability. No? So there are other questions. What will be the net recovery on the wetland and diesel installation you presented? Sylvie from Sylvie Rangbold.
Yeah, it's good point. We for the wetland we estimate about 97-98% overall, because it's an horizontal constructed wetland, so there will be no free floating water on the system, so we have less issues with evaporation there. And then the total desalination train will be around in the upper 80s, close to 90%. So the overall water recovery will be between 85 and 90%.
Then a statement from Kerstin Krömer. We need a funding for innovative full-scale water reuse projects. That's clear. Looking at the global scheme, so we know that we have many ZLD plants and MLD plants all around the world, not only since yesterday, but for decades. In the United States, for example, inland, we have a lot of ZLD plants, in India too, as most of you might know. But I think we have to continue to work on this topic. No? So generally, with respect to many things, but we have to, and Niels, you showed it, I think. Maybe you can say some words at the end with respect to, let's say, production integrated measures. Now, because from my point of view, end of the pipe solutions, we are away from those solutions. At the end, we have to go into production additionally in order to communicate the production engineers. If you add this or that, we might get problems, and we are self-generating problems for our concentrates at the end of the day while adding chemicals. We are adding thousands of tons of chemicals for water treatment. We are adding anti-scalants, biocides, etc. But maybe some words from you at the end, please.
Yeah, that's a very good point. In fact, we're looking at the total chain of water also on the production side, and it starts with water which is coming in. If the better the quality there, the better you can retain that quality in the process. You can try to cascade as much as you can qualities to lower levels, and then finally treat it. But in fact, the production facilities should look at this water use as products rather than utilities which can be used to each and everyone's belief. So they really have to think twice what they are doing when using water, and by that you can make it more circular within the premises. Yeah.
Right. Thank you very much. Unfortunately, I have to close now. A lot of questions remaining, I guess. However, there's a possibility to contact both of them, Tibor Kretschmer and Niels Groth, and you can ask and discuss with them later on, and even via email. I think both of you are ready for this.
Yeah.
However, we have learned that water use industry is quite challenging. It's also site dependent. So even, I guess, Niels, don't tell anything wrong. when I'm saying that even your sites are completely different with respect to the surroundings, with respect to the production processes, with respect to water management, with respect to infrastructure. We didn't address this point, infrastructure, which is essential for water use in industry and which is highly costly. So this is my last point. You say yes, but
yeah, no, that's true. Yeah, I mean, infrastructure is a major issue. So, and that's yeah, if you can make that an urgency within in a region where you can collaborate with others, also public parties, then there may be ground for that kind of strategic investment in where you don't want to do that all as a single industry. But then you have to develop visions for, say, the next 20, 30, 40 years within a region.
So there are some questions remaining in the chat, but I have to close now. Unfortunately, I say thank you to the presenters, also thank you to the participants, and see you back in the main conference.
Okay.
Bye-bye.
Welcome. Thank you.